Hello everybody, welcome to the Java course. In this video, I'm going to talk about inheritance, which is an important mechanism of object-oriented programming. If we are able to utilize inheritance, we can create subclasses based on the superclasses. So in this way, code reuse can be achieved. That means when we want to create another class that is quite related to a certain class, we don't need to copy all the code from the superclass in order to create a new class that is quite related to that superclass. Instead, I can make use of the inheritance properties to make the code shorter. And by means of inheritance, the subclass can inherit all the properties coming from the superclass. In addition, the subclass can add some new functionalities to itself. So let us see an example by means of the teacher class shown here. In this teacher class, I'm going to have 3 methods, 1 constructor, and some instance variables. All of them are now private instance variables. And the teacher constructor is simply helping me to assign the teacher name, the number of years of experience, and the teacher's position into the instance variables. Okay, for a typical teacher, he or she has to attend meeting, he or she has to teach and do some clerical work. So when I want to create a teacher object, I can do so on the driver class. Okay, I have created a teacher object. The reference variable to that teacher object is teacher1, and the teacher name is Winnie. She has 3 years of experience, and she is now a junior teacher in the school system. So, of course, I can tell teacher1 to do the methods shown here. Here I can tell teacher1 to teach and attend meetings. In this way, I'm going to call the methods from the teacher class. Okay. So let me save it and run it. Okay, we can see that the teacher1 is able to do the teaching and do the attendance of a meeting. Okay, so it is quite similar to what we have learned for the class creation and instantiation. Of course, we can also tell teacher1 to do the clerical work. Save it, run it. Yes, teacher1 is going to do the clerical work for the school, which is simply following the method from the teacher class. Okay. If I want to set up an English teacher based on the teacher class, how can I do that? Actually, I don't need to copy all the code from the teacher class in order to create an English teacher class. I can simply derive the English teacher class based on the teacher class. So how can I do that? We can follow such convention shown here. Public class English teacher extend teacher. Okay, when I use the keyword extends, I'm going to derive a new class from the original class called teacher. And for this teacher class, what can I put inside the class declaration? I can put some instance variables which is specific to the English teacher class. So when I create an English teacher class from the teacher class, the instance variables coming from the teacher class will all be inherited to the English teacher class. So in the English teacher class declaration, I don't need to repeat the name, years of experience, and position instance variables, which are already inside the teacher class. For an English teacher, I would like him or her to show the English certificate level to the principal. It is quite special for English teachers to have attended a certain examination in order to tell the employer that he or she has got a satisfactory English certificate level. So this is an instance variable specific to the English teacher class. It is not present in the teacher class, okay? Now I'm going to create the constructor for the English teacher object. Okay, an English teacher of course has a name, the number of years of experience, the position, as well as the English cert level from the instance variable, which is specific to the English teacher class. So N here means the name, Y means the number of years of experience, P means the position, and C means the cert level. Because the teacher class has already prepared a constructor for us, when I set up the English teacher constructor, I can make use of the teacher constructor. So how can I use the teacher constructor? I can make use of the super keyword. Here super means the superclass. That means I'm going to make use of the constructor from the teacher class, which is a superclass of the English teacher class. Here N means the first parameter, Y means the second parameter, and P means the third parameter. So I simply follow the order of the teacher constructor when I set up the English teacher constructor. And for C, which means the cert level, I need to obtain the cert level from the English teacher constructor. So for the instance variable which is specific to the English teacher class, I can do this ordinary assignment in this way, so that the constructor parameter will be passed to the instance variable of an English teacher object. Okay, so this finishes the English teacher constructor. The most important thing is that we use the super keyword to make use of the superclass constructor. Okay. Of course, I need a method pertaining to the teacher class only to obtain the English cert level. Okay, this is a pretty simple method pertaining to the English teacher class. And we have to notice that the English teacher class has already inherited all the methods from the teacher class already. So an English teacher is already able to attend the meetings, already able to teach, and already able to do clerical work. In addition to the inherited methods, the English teacher class can have its own method. So now I'm going to create some new methods for the English teacher class only. I can tell the English teacher to teach English. How can I do that? The teaching action is quite similar to the one for the teacher class. Okay, if I want to make use of the methods from the superclass, I can use the super keyword again. Okay, in this way, I'm going to call the teach method coming from the superclass. So when I tell the English teacher object to teach English, I will simply tell the English teacher to say this sentence out. In addition to this sentence, I can tell the English teacher to do something more. Okay, the English teacher can also tell the students that the topic to teach now is poem writing. So the English teacher has a new method called teach English, and this teach English is based on this teach method from the superclass. And after you calling the superclass, the teach English method can also make use of other strategies to do the teaching. For example, he or she can tell the topic of the English class. Okay. If an English teacher wants to do some specific clerical work other than the one shown on the teacher class, the English teacher class can override the method from the teacher class. What does it mean by overriding? Okay, English teacher class has also a method called do clerical work, and the return type is also void. So the method signature is the same as the do clerical work method on the teacher class. Okay, both are going to have a return type of void. So in this case, the English teacher class is going to create another method for the do clerical work method. Okay. The new method is like that. An English teacher is going to do clerical work for the English students, not for the school. So when I have the same method signature for the do clerical work method in the English teacher class, I'm going to override the method coming or inherited from the superclass called teacher. So this completes the English teacher class. Okay, I can go back to the driver class and create an English teacher object. So now I create an English teacher object. The reference variable is called teacher2. Okay, the teacher is called Peter. He has 6 years of experience, and he is a senior teacher, and he has got a certain level of 2 for English teaching. So I simply use the constructor for the English teacher class, which is based on the superclass called teacher. I can tell teacher2 to do something. I can tell him to teach English. I can tell him to attend meetings. I can also tell him to teach. So let me try to run it. Okay, when I tell the teacher2 to teach English, I will simply call the teach English method from the English teacher class. Okay, so for this method, I will first call the superclass method called teach, which is in the teacher class. For teach, I will say that I'm teaching now. And in addition to this teach method from the superclass, I'm going to tell the reader that the topic to teach is poem writing. And when I tell the teacher2 to attend meetings, I simply tell this object to use the method from the teacher class, which is already inherited for the English teacher class. So I will have the same statement as the method from the teacher class. Of course, English teacher has inherited the teach method. So when I simply call the teach method for teacher2, I will go back to the teacher class, which is a superclass, and I will print this statement out. I'm teaching now. Okay. So for the teacher2, teach English is a new method pertaining to the English teacher class only. So in this case, we can say that teacher2 is an instance of a teacher class, because teacher class derives the English teacher class, and since teacher2 is an English teacher shown here, we can say that a teacher2 is an instance of the teacher class. How can I verify it? I can make use of the instance of keyword to check this relationship. Yes, I will get true. That means teacher2 is really an instance of the teacher class, even though teacher2 is an instance of the English teacher class directly. We can also say that teacher2 is an instance of teacher because English teacher comes from teacher. Okay. So in this situation, we can say something like this. An English teacher is a teacher. So the format is like that. A superclass is a subclass is a superclass. So this relationship holds in this kind of inheritance hierarchy. Because English teacher is a teacher, we can label English teacher object as a teacher. What does it mean by that? I can show you an example in order to illustrate this property. Okay, here I want to create a new English teacher object. So I would have 4 parameters in the English teacher constructor. I just follow the constructor pattern in the English teacher class. Okay. But I would label teacher3 to be a teacher. That means even though the object is of English teacher type, I simply call this reference variable to have a teacher type. This is allowed because an English teacher is a teacher. So I would be able to use a superclass data type to help me declare an object from the superclass type. From the subclass type. I would like to say something more about the label issue. We know that teacher3 is actually an English teacher. Okay, but after it has been labeled to be a teacher class, can I still use the methods specific to the subclass? The answer is no. So we can see an example like this. Okay, I know that teacher3 is actually an English teacher. So for now, it is labeled to be a teacher type. In this situation, I cannot call the getCertLevel method from the English teacher class. Why? Because a teacher class has no such method. When we look back to the teacher class, we have no such method as getCertLevel. Okay. So even though the actual object is of English teacher type, after it has been labeled to the superclass, I am not allowed to call the method from the subclass any longer. Okay, getSubLevel is the method pertaining to the subclass only. But after I have labeled the object to the superclass type, I cannot go down to the subclass hierarchy to run the method from the subclass. Okay, so this is an important property of inheritance. You have to remember this situation very carefully. We know that teacher3 is actually an English teacher object, but now it is labeled as a teacher type. So in this situation, what will I get when I do this kind of operation? If I want to tell teacher3 to do clerical work, which of the methods will be called? The one from the superclass or the one from the subclass? For this situation, we have to remember the property of method overriding. When we have this situation, the method from the actual object type will be called. The actual object type is now an English teacher, so the do clerical work method from the English teacher class will be called. That means I will print the statement out as doing clerical work for English students. Let me see the answer by running it. Yes, I will get the result coming from the method in the subclass. So we have to follow the actual object data type. The actual object data type now is English teacher. The teacher type is simply a label of the object, not the actual type of the object. Okay, we can set up an array actually to store all the 3 teachers mentioned in my driver program. How can I do that? I can create an array of teacher references. I have 3 teachers, so I would have an array of 3 elements. So this teacher array is a reference variable to an array that stores teacher references. I can put teacher1 to the first element of the teacher array. Okay, I can do the same for the remaining 2 teachers. But we have to notice some very important conditions now. Teacher1 is a teacher. Okay. The object type is teacher, and the label type is also teacher. Teacher2 is an English teacher. The actual data type is English teacher, and the labeled data type is also English teacher. but teacher 3 is an English teacher with teacher label. The actual data type is English teacher, but now the object is having the teacher data type as the label. So when I tell all the teachers to do the clerical work, what will I get for individual teachers? I can make use of for loop to investigate the result coming from different teachers. Let me run it. Okay, I would get these 3 statements from each of the teachers. For teacher 1, I would simply call the ordinary method from the teacher class. And for the second teacher, of course, I will call the method coming from the English teacher class, which is this one, doing clerical work for English students. But for teacher 3, we have to notice that we will call the method of actual object. So in this case, teacher 3 is actually an English teacher. Okay. So the method coming from the English teacher class will be called for teacher 3, even though the label is now a teacher label. So I would have doing clerical work for English students as the answer coming from the third teacher. Okay. So that is an important property of inheritance. When we have method overriding, the actual object data type will have a role in controlling the method to use. Okay, we already know that teacher 3 is actually having the teacher label. Actually, can we turn the teacher 3 to the English teacher data type again? Yes, we can. We can make use of the downcasting mechanism. If I really want teacher 3 to get the certificate level for me, I can't do so at this stage because the teacher label has restricted our use of the methods coming from the English teacher class. If I really want to get the cert level from teacher 3, I can do something like this. Okay, here I'm going to downcast teacher 3 from the teacher label type to the English teacher label type. And for teacher 3 now, it is stored in the another reference variable called teacher 4, whose data type is known as English teacher. So here I'm doing the downcasting action to make teacher 3 from teacher label type to English teacher label type. And I would store the English teacher label type to another reference variable called teacher 4, whose label type is English teacher. Okay. Now I can tell teacher 4 to do some method specific to the English teacher class. So what will I get for this printing statement? I will get 1. Why? Because it is the cert level obtained by teacher 3. Okay. Now I simply use another reference variable to indicate that particular object, which was already downcast to English teacher type. Since a teacher4 is now an English teacher data type, I can use the method pertaining to the subclass, so I can get the third level. Alternatively, we can get the third level of teacher3 directly, even though the teacher3 is actually of teacher type, which is a label type. Okay, this is a pretty long statement. What I'm going to do is that I'm going to downcast teacher3 from the teacher label type to the English teacher label type. And then after I've done this downcasting, teacher3 is now having the labeled type of English teacher. And since the English teacher type is allowing me to do the get third level method, I can simply do the method after the downcasting directly. And for this statement, we have to take care of the parentheses. The first parenthesis, pair of parentheses here is going to do the downcasting, and the second pair of the parentheses here is going to give the particular object reference. And after I've got the object reference, I can tell this reference to do the get third level method. So we have to notice the pairs of parentheses. Let me try to run it. Yes, I can still get one, which is the third level of teacher3, shown here. Okay. The next topic to discuss is the object reference assignment issue. So let me create a new teacher first. Okay, I have a new teacher whose reference variable is teacher5. Actually, this teacher is actually an English teacher, and the label type is also an English teacher. Okay, what am I going to do now? Now I'm going to create a new object reference, which is simply pointing to the object created for teacher5. And for this teacher6 object reference variable, the label type is teacher. So we have to notice the difference in the label type for the two reference variables. Okay. In principle, both reference variables teacher5 and teacher6 would point to the same object, which is of English teacher type. This kind of object reference assignment is quite similar to what we did for other object data types, strings or some other user-defined types. So both reference variables would refer to the same object. And what will happen if I'm going to tell teacher6 to do something? if I tell teacher 6 to do clerical work, which of the methods will be used? Let me see. For teacher 6, I will get doing clerical work for English students. Why? Because even though teacher 6 is labeled as a teacher label type, this object is going to do the methods coming from the actual object type. So the actual object type is now an English teacher. In this case, teacher 6 is still doing the methods coming from the actual object data type, which is this one, doing clerical work for English students. So that means we have to notice that if method overriding occurs, the actual object data type will win the competition. So the idea is like that. The method to do would follow the actual object type if overriding occurs. A final point to discuss for inheritance topic is the protected member issue. We can have another example like this. Now I have a person class. I have a private instance variable called age. I have two methods. One is the getAge method, and the other is the setAge method. For this person class, I have not set up my own constructor, so I would use the default constructor. Okay, and if I am going to derive another class based on the person class, I can do something like this. So now I created a student class, which is inherited from the person class directly. Okay. For this student class, I have a private instance variable called E of study, and of course, the student class has already inherited the getAge and the setAge methods from the person superclass. And for the student subclass, I'm going to create two more methods specific to the student class only, which is setYear and getYear. Okay, so for a student object, it is not allowed to access the private instance variable called age from the person class directly. So let's see an example. I set up a student object by using the default constructor of the student class, and the reference variable to that student is known as student1. I can set the age of that student to be 15 years old. Age is already inherited from the person class, so the age instance variable for the student object is already inherited for us, so I don't need to declare the age in the student class any longer. Of course, the age here is a private instance variable pertaining to the person class, so even the subclass is not able to access the superclass instance variables directly because of the private keyword here. If I want the student object to access the instance variable from this superclass directly, I can make the access modifier to protected other than using the private keyword. Okay, when we use the protected keyword here, it means that the instance variable called age is accessible within the same package. What does it mean by a package? A package is simply the whole folder that stores all the source code files. So the age instance variable is known to other classes in other source code files. Okay, so student class is inside the same package as the person class here. So we can say that the student class is able to access the age instance variable directly. So we don't need to set the age by using the method given by the person class. In addition to using the setAge method, I can set the age directly. So after I have set up the age instance variable to be protected, I can simply make use of the reference variable .age format to set the age of student 1 to be 16. Of course, I can still use the method coming from the person class, although it is no longer necessary. So for both printing statements, I should be able to set the age differently. Save it, run it. Yes, the first setup is to turn student 1's age to 15, and the second assignment statement here is that I'm going to turn the age to 16 directly by using the reference variable private instance variable format. So I can use the dot notation to set the instance variable directly if it is now protected. So in this case, we don't need to use the setAge method from the person class any longer. So if the instance variable is protected, we can access it directly, even though this property comes from the subclass rather than the superclass that holds the instance variable initially. So after the introduction of inheritance in this video, I hope you're able to understand how we derive some other classes based on the superclass, and we should be able to understand how we can make use of the label issue to help us understand the correct method used from the superclass or from the subclass. This is the end of the video. If you have any questions about my video, feel free to leave your comments on the comment section below the video. If you like this video, please give me a like and please subscribe to my channel. Thank you for watching.